Hey, code breakers and meaning makers, Mr. Brennan here. This summer I took a class in encryption that I thought was really wonderful, and I've been waiting because I wanted to make that connection between encryption and algebra. So yesterday we talked about Polybius square, and today we're going to have this introduction to algebra as well. So let's get started. Steganography is when you have information that's hidden, like an Easter egg in a website or a game, and you don't know that it's there because it's hidden. So there can be information that you don't notice just because of the way it is. So, and yesterday we did some cryptography where the information is there, like within this pigpen cipher, this says cryptography. You know it's there, you just can't read it unless you have a key because the information is protected. So this is the Polybius square. This guy here, his name is, any guesses? Yeah, good. His name is Polybius. So he is a very famous ancient Greek dead guy. He lived about 2,200 years ago, and he did not invent the Polybius square, but he did talk about it. He was a historian, so he talked about it and how this Polybius square works. Like if I have a number like 32, then I would come, these are the tens, and the first letter would be M. And then number 11 is man, or M-A. So, and then if I had like the number 14 would be mad, because 1 and 4. So you can see that if I have just some harmless looking letters, I can be doing steganography and cryptography at the same time. Hidden meaning where I'm using letters for numbers or numbers for letters. So let's get talk to algebra because it has that same substitution. The part of math that letters or other symbols, and we're going to use letters, represent numbers and quantities. So you've been doing that for a very long time since you're in first grade, talking about how many monkeys fill in the blank. So there's some pieces we need to know for these algebraic expressions. This one is a vocabulary word. You're not going to use that often, but you should know what it is. It's a coefficient. And a coefficient is times a variable. So a variable is a letter that we're using to represent a number. Now it varies. What number is it? We don't know because we don't have an equal, so we can't figure out this expression. It could be 0. We have 4 times 0 is 0 plus 7 equals 7. It could be 1. 4 times 1 is 4 plus 7 equals 11. It could be 2. So 4 times 2 is 8 plus 7 is 15. That's called the variable because it varies or it changes. This 7 here, or any number by itself, is called a constant because it doesn't change. It's always worth 7. Exponents, you've seen before, but we haven't talked about very much, have 2 parts, the base and the exponent itself. This one is called 3 to the 4th power. And that means, really, there's not a whole lesson here. It just means 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. 27 times 3 is 81. So this just, you see this little tiny number there, it just means to that power. So the last thing I want to talk about is the order of operations. And we talked about this when we played crypto, PEMDAS. Some people remember that like that. I remember, please excuse my dear Aunt Sally, which is just a mnemonic device for parentheses, exponents, multiply or divide. It could be switched around either, or add or subtract. So it could be whichever one comes first. It could be, please excuse dear my Sally aunt. So I hear you asking yourself, well, Miss Brennan, what does that have to do with us? Well, this is our work for today. We're going to talk about algebra and PEMDAS and exponents. So evaluate the expressions when W is 1, I 2, and 3, T equals 4. So I'm going to substitute these letters for those numbers. So if I have 15 minus N, that just means 15 minus 3. So the number would be 12. And you can see how that would work. Where would 12 fit in the Polybius square? We just talked about it. How about, let's try another one. We know that another way that we say times is the little asterisk. E times R plus 13. What's E is 5 times r is 6. 5 times 6 is 30. So then plus 13 must be 43. I wonder where that fits on the Polybius square. Now, I kind of started going crazy with these a little bit. Sorry about this. W plus I, that's 1 plus 2 divided by n. So I've got 1 plus 2 because I have to do what's in the parentheses first. So I do this first. 3 divided by 3 times. So you see how we go. Anyway, I hope you have fun with this. This is what we're doing most of the week. And I'll see you at office hours and on our help.